Hi, I'm Isla, and you're watching Coding at Home, a regular educational program that you can catch right here on 10 Peach during Term 2 and online. Our mission is to show you just how fun and awesome coding can be. In the last episode, we showed you how to start writing code using Python in idle. We showed you how to receive a user input and save it in a variable. We also learned the print and the input statements and to write a simple program that would print a personalised welcome message when a user entered their name. Then we got a bit fancy and used concatenation to merge words with variables to create an interactive message. Sasha showed us how to use if, elif and else statements to create branches in our code. We're going to use these again in this episode, so here's a bit of a recap.
Remember, we used a variable to store the name we entered. We think of variables as a box we can store things in, and the label or name should tell us what's inside so we don't get confused when our program gets bigger. Printing out the message using our name variable was pretty easy too. We used concatenation to combine the words hello, the variable name, and our message to the user.
All of this was a really good start in making an awesome chatbot that remembered our names. But to make it even better, we're going to have to dig a little deeper into some of the techniques in Python that we can use to make our code easier to write, read, and maintain. The first of these is called repetition.
Imagine you're throwing a ball towards a target and you've promised yourself that you'll hit the target at least once before you can stop. We can think of this as a loop. Until we've hit the target once, we have to keep throwing.
Sometimes our programs need to repeat the same thing over and over again until we reach a correct or a valid answer. This is where we can use repetition. A good example of repetition in Python is the while loop. We can write the program as if we're throwing the ball.
While target, not hit, throw ball.
In this, we can see a similar structure as our if statements from before. We have three major components of our while loop.
The while keyword, to tell the program we want a while loop. A condition, in this case, target not hit. This will tell the program when it should stop looping, which is once the target has been hit. The body, what we actually want to repeat. In this case, throwing a ball. Just like our conditional statements, this section needs to be indented one level. Remember, we need to be precise or our code will create a syntax error.
Let's write some code to show how this works. I want to write an awesome program that'll check if I'm the user. I'll need some user input, and because I want it to keep checking that it's me, I'll need to use a while loop. My while loop will need a condition and an action. The condition to check for will be any user that's not me. To do this, I'm going to need a new sign.
Earlier, we used two equal signs to check if two things were equal. To check if two things are not equal, we use an exclamation mark and an equal sign.
The action will be to print access denied and ask again who the user is. Let's write the code together.
First, we need to collect some user input and save it in the variable user. Now for the while loop. I'm being careful to check my syntax and making sure that I use a colon after the condition in my while loop.
So this reads, while the user input does not equal Isla, print access denied. Ask for the user's name again and repeat the check for Isla in the user input. Once Isla is entered, the loop should stop and the last line will print. Let's give it a try. Now to try my name. Hang on, why did the program not welcome me when I type my name? When we find something wrong in our code, it's called a bug. To remove that bug, we need to go through line by line to see what went wrong. Fixing our code is called debugging.
The first line is working because the user variable is set. what about the while loop? Oh, look at the condition. It's expecting my name with a capital I.
Computers are very particular about that sort of thing. I'll try again. Awesome! Now I have a program that'll only greet people who type in my name correctly. I'm feeling a bit hungry right now. It'd be great if I had a sandwich making robot. Unfortunately, I don't have one of those yet. But how would I go about describing how to make a sandwich to a robot? It'd need to know all the little steps, like get 2 slices of bread, butter one side of each slice, add filling between the slices, and then put the 2 slices together around the filling. What if we wanted the robot to make lots of sandwiches? It would take a long time to type all the code in, even if we copied and pasted it. And it would be difficult to change how we made sandwiches, because the same code would be in so many places. This is where functions come in. A function is a block of code that we can write that contains all of the parts we need to complete a larger task. In fact, we've been using some functions this whole time. Some statements in Python are functions, like the print statement and the input statement. Let's write a function of our own for making a sandwich. First, we start with the def keyword to show Python that we're going to define a new function. This is followed by the name of the function. Functions can be named anything, but just like with variables from our last episode, they must start with a letter. And the convention in Python is that they start with a lowercase letter. Then we indent one level and write the body of our function. In this case, each line of code in the body is a step in making a sandwich. Let's write a function called makeSandwich. Now we have written the function, but it won't do anything we can see until we call it. Calling a function is when a function is run in the code. When we type print, we are calling the print function. So I'll add makeSandwich to my code. Now let's run it. I'm getting pretty hungry. That's pretty cool. I wonder if I put makeSandwich inside a while loop, would I make infinite sandwiches? Now you know how to use while loops and functions to handle all of the repetitive tasks you'll ever need to do. Make sure you pay careful attention to the syntax as you write.
It's important to have the brackets and colons match, as well as making sure the body section is indented so the computer knows the structure of your code. Loops are a great tool for repetitive problems, and functions give you a really neat way to reuse parts of code all through your program.
Have a go at using some of these techniques in your chatbot. I know I will once I've finished eating all these sandwiches. Welcome back to Coding at Home. Before the break, we learnt more tips that we can use in our Python code. A little later, we'll find out how we can make our code more robust. But first, let's catch up with some big thinkers who'll give us their vision of the future.
Have you ever wondered how you distinguish globular clusters from the cosmic environment, or how the brightness of a supernova can reveal how much dark matter is in the universe? Well, wonder no more, because today we're at the Sir Thomas Brisbane Planetarium to find out how artificial intelligence is being used to find the answers to these questions. Hey Sam, you're an astrophysicist. It's such an impressive title, but what do you actually do?
So an astrophysicist is someone who studies space. If it's in space, I care about it. If it's dark energy, dark matter, the fate of the universe, or just galaxies, stars and planets, I want to know about it.
What are some of the interesting projects that you've worked on?
So the project that I'm working on right now is with the Dark Energy Survey. So we're trying to constrain the nature of dark energy. Dark energy is this mysterious anti-gravity force in the universe that's causing the universe to expand. And not just expand, but get faster and faster in its expansion. And to do that, we use supernova. We observe supernova. Supernova are just exploding stars. there's an issue. Stars can explode in a whole bunch of different ways, but we only care about a single way, because there's one way when stars explode, they explode with the same brightness. And that's what we care about. If you have two things that are the same brightness, but one of them looks 4 times dimmer to us than the other, then it must be twice as far away. So you can use that to measure distances in the universe. So we have to take all the data we have from the Dark Energy Survey and train these machine learning classifiers to say, okay, this is a type 1a, this is a type 2, a type 2p, a type 2n, this is a quasar. There's so much stuff in the universe, and we need to get rid of everything except for the specific sort of object that we care about.
Now, you mentioned machine learning. Is that one of the AI tools that you use in your project?
So machine learning is essentially when you ask a computer to go away and train itself and then come back and give you answers. So you've probably seen many examples of this in your life. If you have any video streaming services, you probably give things thumbs up, thumbs down, 5-star, 1-star. And so what you've done is you've given data to them, what you like, what you don't. Their algorithms have learned, hopefully, your preferences, and then they can make recommendations. So it's very similar to what I was doing, where I say, well, I've looked at 100 objects myself, and I know that this one's a galaxy, this is a globular cluster, this is a star. The algorithm learns from that, and then it says, based off that, here are all of the globular clusters that we think exist.
Now we know how artificial intelligence is advancing our knowledge of outer space, let's discover what the future of AI looks like back on Earth. Now, Marek, you're a professor at QUT. How are you using this cutting-edge technology?
Stace, there are 2 ways we're using those technologies. One of those ways is at work, helping us with doing what we need to be doing at the university. The other way is when working with students, so basically teaching our students. We have social media listening centers where very sophisticated algorithms are trying to understand the conversation on Twitter or on other social media platforms, and we teach students to work with those algorithms so that when they're back at work, or where they get employed, they actually have those skills.
What are some examples of how AI is already influencing us every day?
Think about ride-sharing platforms. There are algorithms that decide which driver gets the job. But also, if a driver doesn't have, a good enough rating, and the rating falls under a certain level of stars or whatever the rating is, that algorithm can fire the driver. So there are algorithms that are like our managers. We have to deal with them, and they decide whether we work or not.
Can you explain how it's all evolving?
Imagine being able to tell your dishwasher, hey, buy a dishwashing liquid that's good for the environment, and it's not too expensive. And then your dishwasher will shop around and buy the one that you need. So this is a second stage of evolution. The first one was what I call hard-coded. They just do the same thing all the time. The second stage is what I call preference-based. You tell the dishwasher what your preference is, and it just does it. There's a third stage. When you have a smart fridge, a hard-coded smart fridge will just replenish what you have inside. So if you remove milk, you're out of milk, it will order more milk. A preference-based fridge will understand that you want healthy milk and not maybe the cheapest milk or something along those lines. The third stage will be an inspirational fridge. That's a fridge that will try to understand your needs, what you expect, and then it will try to surprise you. Maybe it will buy you a drink that you've never tried before. Maybe it will get you an almond milk just to see whether you like it. That's a pretty advanced level. We're not seeing such algorithms out there in the wild just yet.
So if artificial intelligence is influencing how we work, think and live, how will it influence our jobs in the future?
In future, we'll have codies. They will be a bit like tradies, but they will be really, really good at working with code. This means that, for instance, imagine you will buy a robotic lawnmower and install it in your backyard. Most likely, it's a bit too tricky for you or me to configure it so that it works, the best. You will just pick up your phone and ask for a codie to come in, and they will set everything up, configure everything. So codies will be the tradies of the future.
From supernovas to smart fridges, When it comes to artificial intelligence, it sounds like the future is already here.
Welcome back to Coding at Home. We're really making strides with our coding in Python, but now it's time to take a big leap. Let's level up our coding by using functions and repetition to save us time and space.
Hi there, my name's Daniel. I'm a designer and a programmer at Micromillion Robotics. We build robots and software that teach programming for schools, and sometimes even universities. Robots are a great way to learn programming while seeing how your code can respond and affect the world around it. In a lot of ways, programming a robot is very similar to writing a chatbot. The robot has to respond to what its sensors see in the world, just as a chatbot has to respond to the messages that it's receiving. Last week, we used the input statement and branching to print different messages depending on who was using our chatbot and what commands they wanted to use. Now that we have a simple greeting message, we need to make the chatbot a bit more interactive. Let's add a simple line that tells our user what our chatbot does. Hi there, I'm Chatty, the cyber security chatbot. One of the easiest ways to add more interaction to our chatbot is to add more if statements that ask our user questions. In this case, we're going to be using cybersecurity questions. How about we ask our user if they know what a phishing email is? I'm going to add an input statement, asking the question and then record the user's input in a variable called answer. I will also tell my user how to answer the question by selecting A or B. My condition will be if the user enters B, the action will be to print an affirmation that the user chose the correct answer. If the user inputs anything else, they will get the message telling them that they were incorrect and also telling them the correct information. This is looking pretty good, but I think we need to give it a quick test. All right, what is your name? Well, I know this one, Daniel. What is fishing? I like catching fish, so I'm gonna go with A. I got it wrong, oh well. That's looking pretty good though. We have quite a bit of code now. The smarter we make our chatbot, the more code we're going to have to add. This is going to make our code a bit cluttered and hard to read. And what happens if we need to change our greeting message? Well, we'd have to go back to each line with a greeting message on it and change it manually. Wouldn't it be easy if we only had to make one edit and that would change all of them? One way we can reduce complexity in our code is by using functions. Functions are a brilliant way we can reduce the amount of code we need for our chatbot to work. Let's make a greeting function that takes our user's name as an argument. Our first step is to create our function with def. Next, we give our function a name that'll describe what the function does. Let's call it greet. Then we add brackets. Inside the brackets, we define what arguments will be used by the function. We know we want our greeting to change depending on what the user's name is. So we will make an argument called user. The last step at this stage is to end the line with a colon. Now we need to write the body of the function, which is what the function will do. Every time we run the greet function, we want to print a message to our user. Let's put a print in the body of our function and type in hello there plus user plus exclamation point. You can see that the body of the function is indented. That's our complete function. It's going to sit above the rest of the code so that Python knows what we're talking about when we call the greet later on. Now we can go back through our code and replace all our print statements with the greet function. That looks much better. And now, if we want to change our greeting message, we only have to change it in one place. Now, I want my chatbot to be a bit of a cowboy, so I'm going to make it say howdy. Howdy there. So now, no matter what name our user enters in our chatbot, it's going to respond with a friendly howdy. I've noticed something with my chatbot. Can you see a pattern here? We have a lot of branches, and they all call the same function. Because we are calling greet every time in our if, elif, else statement, the same action is being run for every condition. I don't think we need the if, elif, else statement at all anymore. Now that we have the greet function, we can simplify our code by replacing the if, elif, else statement by calling greet with user as the argument. And if we ever need our chatbot to greet our user again, All we have to do is call the greet function. Our question and answer part of the code is okay, but there's one small problem. Anytime the user enters anything besides a capital B, they're going to get the error message. We need to help our user input a correct response if they enter an invalid response. We need to keep asking them until they enter a correct response. This sounds like the job for a while loop and a condition. To keep our while loop running until the user enters a valid response, we will need our while condition to read while the user's input does not equal A or B. We need to check that the answer does not equal A or B. This is what it's going to look like. Our condition is that the loop will run while the answer is not B, or while the answer is not A. Note that the variable answer is used each time we check it. All our code running inside the loop will need to be indented once more. I will also need to add an else to ask the input again. Let's test it out. I'm going to start by entering in some invalid responses first. Awesome, it worked. Now for a valid response. Uh-oh, that's not good. Looks like Python's entered an infinite loop. Good thing, we can just close the shell. Let's go back to our code and start debugging it. It all seemed to work fine until we entered a valid response. Once I selected B, the value of the answer was set as B. This means my loop condition is met, and my loop goes on forever. I can fix this with a command called break. We can add break anywhere inside the loop, and the loop will stop as soon as it's run. Let's add break after each valid response in our loop. Let's give this a test and see how it runs. An infinite loop usually signals that there's a problem in our code. We avoid that by using break, but really, we should look for a mistake in our condition. See if you can rewrite the while loop with a better condition. Great, now we can add even more interactivity to our chatbot, and we can keep trying even if we make a mistake. Today we've covered two really powerful tools in programming. First, functions can simplify your code and make it easier to change by writing a reusable chunk of code once. And second, while loops allow you to repeat a section of code until a condition is met. With a few small changes, our chatbot now works even if our user makes a mistake. See if you can use loops and functions to make your chatbots even chattier. Good luck!
Well, talk about levelling up. We really are on our way to becoming coding experts, and we nearly have all the tools we need for our coding projects. Remember, if you want to catch up on any part of the coding process, you can see previous episodes online at 10play.com.au. We'll catch you next week with some final tips plus some advice on evaluating and presenting your project. Happy coding!
Authorised by the Queensland Government, Brisbane.